Sets are simply powers with rational exponents, and if simplified will result in an irrational power. Just want to explain that power. I know most students are used to the fact that this exponent here is called a power, but actually a power is the whole um, exponent, or basically it's simply the base and the exponent. This whole thing is what we refer to as the power. So if we have a power with a rational exponent, so basically this is the rational exponent and this is a power. Now if you have a power with a rational exponent, if you were to simplify this, it will give you an irrational power. Basically it will just give you an irrational number. Now you can try and find the square root of 3 and realize the square root of 3 is simply an irrational number. It gives you decimals that are not recurring at all, okay, or are not finite, okay. Now said laws. Said law simply, the first law simply says that if you have a power inside the bracket, you simply take the exponent of the base and divide it by the root. Okay, in this case it is the nth root, so basically I will simply take m and divide it by n, and hence I have a to the exponent of m over n. And please note that this n here must always be greater than 0. Okay, n must always be greater than 0. Now, if I have this, if I have 2 and the cube root of 2 squared, it is the same as 2 to the exponent of 2 divided by the 3, because we're finding the cube root. Remember I said you take the exponent, you divide it by the root. So basically your answer here will be 2 divided by 3. And if I have the square root of 3 cubed, you will simply take that exponent of 3 and divide it by 2. You need to understand the square root simply means that here we have 2. So basically outside there we have 2. Square means 2, remember that, okay? Here we have 2. So basically you simply take in this exponent, you divide it by the root, which is 2. Hence we have 3 to the exponent of 3 over 2. Now, another set law. It simply says that if I have the root, the nth root of a times b, I can simply split the roots and give a the nth root and b the nth root and multiply them, okay? That's what it simply says. When sets are multiplied, they can be split apart and rooted individually. Basically, if I have the cube root of 8 times 27, it is the cube root of 8 times the cube root of 27, which is 2 times 3, and 2 times 3 will be 6. Now, if I have n multiplied by m root of a, you can simply decide to put n outside or you can put m outside. It's totally up to you. So it's like you're finding the nth root of the mth root of a. When taking the root of a root, it is the same as taking the single root to the product of both roots. Okay, so basically when you're finding a root of a root, you simply find the root of that number, but you multiply the roots. Basically, you're simply raising them to a product of both roots. Here's what we have here. So basically, if I have the square root of the cube root of 64, it is the same as though I'm simply multiplying 2 with 3, and it will be the sixth root of 64, and the sixth root of 64 will simply give me 2. Now, how do we simplify this? Please note that when you simplify the roots, you need to pay attention to what type of root you have, okay? If we have a square root, make sure that you have a perfect square inside the root. Basically, that's 72. You will find 2 factors, and one of the factors must be a perfect square. If I was finding a cube root, then whatever is inside the root, when I find the factors of what is inside the root, I need to find a perfect cube multiplied as a factor multiplied by another factor. In this case, I need a perfect square multiplied multiply by another factor, and the perfect square will be 36 multiplied by 2. Now remember the rule, the law that we did. When you have two factors that are multiplied inside the root, you can simply give each factor its own root and root them individually. Hence, I'm going to have this. I can't find the square root of 2, but I can find the square root of 36, and the square root of 36 is simply 6. You can simply write it as the 6 multiplied by the square root of 2. If I am finding the square root of 75, here I will simply find a perfect square, a perfect factor actually, which is a square. In this case, it'll simply be 3 multiplied by 25, 25 being a perfect square. And obviously 3 is another factor. When you multiply 3 and 25, it will give you 75. Now, as I've said from the previous rule, you will simply split this and you will have cube root, the square root of 3 multiplied by square root of 25. Square root of 25 is 5 multiplied by square root of 3. Now, how do we deal with something like this? The rule is simply the same. You will simply split this, okay? Find factors. One of the factors must be a perfect square. Find factors of 45. One of the factors must be a perfect square. Now, the factors of 20, a perfect square, there will be 4 multiplied by 5. And for 45, a perfect square will be 9. And you're going to multiply it by 5. Now, you will end up having 2 square root of 5 times 3 square root of 5. Note that the square root of 9 is 3, the square root of 4 is 2, but I can't find the square root of 5, that's why I left it as it is. These are like terms, and when you have like terms, please remember the rule. When you have like terms, you will simply add their coefficients, and in this case, there's nothing I can do with I can't do anything with that square root of 5. I can't do anything with that square root of 5. I cannot do anything with that square root of 5. All I'm going to do is just to add 2 and 3 and keep the square root of 5 as it is. 2 plus 3 will give me 5, and I'll have 5 square root of 5. Let's check what we have here. A perfect square for 98 and another factor. A perfect square for 32 and another factor, and a perfect square for 18 and another factor. A perfect square for 98 will be 49, and I'll multiply it by 2. A perfect square for 32 will be 16 multiplied by 2. A perfect square for 18, it will be 9 multiplied by 2. And then you have to split the roots and simply root each factor separately. And when you root 45 separately, it'll give you 7, but I'll still have the square root of 2. There's no square root of 2. I can't find the square root of 2. I can root 16 separately and it'll give me 4, and I can't find the square root of 2. I can root 9 separately and it'll give me 3, but I can't find the square root of 2. Okay. Now from this step, I can't do anything with the square root of 2. I can't do anything with the square root of 2. I can't do anything with the square root of 2 now. Since these are like terms, I can simply say 7 minus 4 minus 3. How much do you get? It is 0 square root 2, and 0 square root 2 is the same as 0. Now, what happens when you root different numbers, but you're simply multiplying them by the same root? Like here, I'm multiplying the square root of 2 with the square root of 3. Please note that when you have something like this, if the root, this only applies if the root is the same. Okay, you can simply multiply whatever is underneath the root and just keep the root. So basically, I'll multiply 2 with 3 and I'll still have the root. In this case, my root is the square root. Okay, now 2 times 3 will simply give me square root of 6. So basically what I'm doing here, I'm simply working backwards. Remember, when you have two factors that are multiplied but they have the same root, you will simply split the roots. In this case, if you have two roots that are splitted, you can simply combine them by raising them to the same root. Okay, it's one of the exponential laws, but you will learn that as we go. Now, what do we do here? Firstly, I'm going to go back to grade 8, where you just multiply the coefficients of the root first. So basically, I will multiply 5 with 3. And what is 5 times minus 3? 5 times minus 3 will give me 15. So I still have the square root of 2 multiplied by the square root of 5. There they are. I started first by multiplying 5 with the negative 3. 5 multiplied by negative 3 will give me negative 15. Now, once you have the same root, but inside the roots, the numbers or the factors are different, you can simply raise these factors, multiply these factors, and raise them to the same root, and this is what you will have. 2 times 5 will give you 10. Hence, I have negative 15 times the square root of 10. Now, this is simply a binomial multiplied by a binomial. Nothing changes. You will simply multiply these two brackets out using FOIL, but you'll realize that the brackets are exactly the same, okay? Except that there's plus and there's minus in each of those brackets. All you have to do here, you'll realize this is simply a difference of two squares. You will just multiply that with that, and that with that. If brackets are exactly the same but the signs are different, you can just use the shortcut method where you multiply the first terms in each bracket and the last term in each bracket. Okay, now I will simply multiply this with that. When I multiply this with that, I will have 2 times 2. It is 4. But square root of 2 times the square root of 2, I'll keep it as it is. Minus 3 times positive 3. So it's positive 3 times minus 3. That will give me minus 9. So basically, this is what I did. Two times 2 is, it is 4. But the square root of 2 times the square root of 2, it will be the square root of 2 times the square root of 2. Now, since we're multiplying two factors and they are raised to the same root, we'll just multiply what is underneath that root, which is 2 times 2, and raise them to the same root, which is the square root. And that's what I'm going to get, okay? Now, in this case, that's how we got the 2 that I just showed you now. And 3 times 3 is 9. 4 times 2, it'll give you 8. And then you'll have 9. Now, I just want to go back to this because remember I taught you this method here from the previous slides. But I just want to modify that. If you're finding the root of the same number, you just cancel out the roots and you keep the number. That's all you have to do, okay? It works the same way with the variables. If you're multiplying the square root of x with the square root of x, you just cancel out the square roots and your answer will just be x. Here I will simply have to distribute, but before I distribute, I will simply split 50 by finding a perfect square and another factor. Split 18, well, factors. A perfect square for 50 will be a perfect factor or perfect square factor for 50 will be 25, and 2, a perfect square factor for 18 will be 9 times 2, and a perfect square factor for 32 will be 16, but you're going to multiply it by 2, and this is what you will have. Now you can actually root each factor, so the square root of 25 will be 5, and the square root of 2 will still be the square root of 2. And the square root of 9 will be 3, and the square root of 2 will still be the square root of 2. The square root of 16 will be 4, and the square root of 2 will still be the square root of 2. Now what you're going to do here is simply to multiply out. I would have used a different method. I was going to add what is inside the brackets because those are like terms, but I'm going to use this method in case you encounter a different expression later on. Okay, I'm going to multiply 5 with 3, it'll give me 15, and I'll have square root of 2 multiplied by square root of 2. And then I'm going to have 5 times 4, it'll give me 20, and then I'll have square root of 2 multiplied by square root of 2. And obviously, I said if you're multiplying the root, the same roots, you just cancel out the roots and you keep whatever number you have or variable. In this case, I'll have 15 times 2 and 20 times 2. 15 times 2 is 30, 20 times 2 is 40, and that will give you 70. You could have done it differently here by saying 3 plus 4 is 7, and then you just take that 7, you multiply it by 5. Okay, that's another method you could have used. You could have added what is inside the brackets first before you distribute or multiply. Okay, I hope we'll encounter a similar example. Please do this as a classwork, as well as this and this.